Hello, going to do a little video demonstration, some of the operation of the Keithley DMM7510, which is a new toy to me, and I'm going to be testing the effect of output impedance and load on a 7 to 10 volt buffer that I'm building for my LTZ1000A based reference. The reference is in the blue box up top. That's a little battery powered ovenized box I built for one of the KX LTZ1000A references. It's stabilized at 35 degrees Celsius. It's currently running on battery. It's been running on battery for a couple days now, and the same thing with the DMM. It's been running for a few days. And over here I have my protoboard with the LTC 1150 operational amp, which is then controlling and driving an LT1010 driver buffer, and I'll be driving 10 volts out of that. It's just some cheap film resistors on there, so it's not going to be super ultra stable. I have some Vichy hermetically sealed oil filled resistor networks on the way, so those I've been waiting for them for a few months. Hopefully I'll have them, I was told, sometime in February. So it's the price you pay when you custom order parts like that. So I'm going to be loading it down with 4.7 meg, 1 meg, 100K, and 10K, and show you some of the measurements and effects of those on the buffer. So let me get this set up here. We'll go ahead and just zoom in on the meter, because that's where all the fun stuff is. Currently I'm just measuring the voltage right off the LTZ1000 right now, 7.161611 volts, and the trend chart you can see there scale at 1 microvolt per division. See, it's fairly stable, quite stable. So here, let me go show all, track latest, all. Okay, so varying plus and minus right there, 1 microvolt. I do have a little bit of filtering turned on, moving average 20 samples, and turn that off. Let's see what happens to let's clear the buffer. And this is just with no filtering. And let's do 2 line count. Show you the faster update rate. Okay, enough playing around here. Let's connect. Oh, one thing I was going to show was the effect of connecting the right now I have it in 10 gig ohm input impedance, and I'm going to connect the input to the LTC1010 and or LT1010 LTC 1150 buffer to the output. As you can see, it really didn't change the output at all. This is, well, of course, 1 millivolt, so make it a little more stable here. Same, 7.16161112, plus or minus 1 digit, and 1 microvolt. So it didn't really change anything. Let me disconnect that and connect the meter to the output of buffer. So pretty well have it set right now to 10 volts. As you can see, and we get set up here to load down the output impedance, or the output of the buffer. Let's go to the chart. Let's get this set up. Okay, so this will be, let's make this a little bit faster. 5, let's do 2. No averaging. Okay, so there we're going to see any bumps. So I'll take my 4.7 meg resistor and connect this, and you're going to see a bit of a jump, but it should return. You can see the jump and return right back to 0. And here is the 1 mega ohm. You see the spike when I connected it, and it's right back to the output voltage it should be. And here is the 100K. Again, at this resolution, not able to see or detect any change. Now let's go to my 10K resistor. That's 10 kilo ohms. It took a little bit longer for it to come back up. Now it's under a pretty significant load. And it looks like it's trying. Let's zoom in here a little bit. So you can see it changed. Let's go scale. Let's make that 1 microvolt per division to make it easy to see. So it looks like let's smooth this out a little bit. Make it a little bit easier to see. Okay, this is with the 10 kilo ohm resistor currently on the output. Now disconnect. I have 20 times moving filter on, so it's going to take a few seconds for it to restabilize. So it looks like 1, 2, 3, looks like about a 3 microvolt change. Now obviously my proto board is not the best test for stability, especially with the cheap resistors I have online, but there's a little bit of additional loss going on with the 10K load that's causing the voltage to overcorrect slightly. So I just reconnected the 10K load. We can see it came up 1, 2, about 3 microvolts. Currently sitting at 2 to 3 microvolts over 10 volts. Disconnect the 10K load, and we're at 1 microvolt under, 1 to 2 microvolts under 10 volts. You do that again with, let's do the 1 mega ohm load. Okay, this is connecting the 1 meg. Virtually no difference. So 10K is pretty significant load. I even tested the output as a dead short. I'll show you. See if I can get both in here at the same time. So this is what happens when I do a dead short on the output. Of course, the voltage drops to nearly nothing. And it will recover. It will take a few seconds for it to recover. The reference never sees the short being buffered, so you can short it the way I have the setup indefinitely. Will not harm the LTZ1000 whatsoever. And it'll take 30 seconds or so for the LT1010 and the LTC 1150 to recover perfectly, but it does. So that was kind of nice. Let's see. What else? Let me zoom back in on the display here. Do a couple more little things. Let's play around with some of the features on this guy. Let's go ahead and put relative on. Go back to the scales. Okay, now I have it referenced or nulled to where we can see the change in microvolts from 0 microvolts plus or minus. It's still recovering, I believe. Yeah, it looks like it's going to be settling in right about here. Let's go ahead and just do a new, let's see here, relative, acquire, home. Now it's zeroed again, and we're at 2 PLC, the moving average filter is on. And let's go ahead and try it one more time. 4.7 mega ohm. Now this is 1 microvolt per division. So you can see it dropped, came right back. Okay, now here's the 1 mega ohm. See, it drops and it is recovering right back. It might be down it might be down 1 microvolt. It's right back there again. So kind of hard to tell at this level. I'm on the 10 volt scale on the meter. It's just being nulled to 7.16 volts, and obviously with this kludge of wires here, this is not an ideal setup for measuring sub ppm, especially with the components I'm using just on the proto board. But still, the stability and repeatability is pretty impressive. And okay, 1 mega ohm disconnected. Let's go ahead and connect the 100 kilo ohm again. Let the meter calm down. Let's clear the buffer. Okay, we'll be able to see. Here's the 100K connected. I didn't even really see a drop. Let's do it again to see if I can see. Okay, it's disconnected and 100K reconnected. Well, it's recovered quite well right there. No change at all. 100K ohm. Now let's do the 10K one more time. We'll see this one. Okay, 10K connected. See it recover. And see it overshoot. And see if it recovers and comes back down. At this point, I believe it's just a little bit of loss in the negative feedback on the op amp that's causing the overshoot. Since I'm drawing current at this point, and the way I'm tapping off the proto board is not ideal. So that'll be fixed once I build it and install it inside the 10 volt reference board will be installed in the oven as well to keep everything nice and stable. But obviously I don't expect to really need to be stable down to a 10K ohm load. But it's kind of cool to do it. Well, there you go.